Hi, welcome back to my YouTube channel. In this video we're going to see how we should solve the integral of x to the dx minus 1. But can we have dx in the power? Well, it turns out we can have it in a specific form. So to do this integral, I'm going to multiply both sides and divide them by a dx. Now this looks better. So I'm going to have this integral, this expression with respect to x. If you remember, dx is a very small change in x that approaches 0. And basically, the dy dx chain, if you have taken calculus in university, you notice that it represents very small change in y over x. That's why we treat it as dy dx, as a fraction. So right now, if this is a very small number, such as if you remember these limits, h approaches 0, f of x plus h minus f of x over h. If you remember this, you remember that we had to remove the discontinuity of the limit, for example, the derivative definition of a limit, and then solve for it. And then, and also here, we have to treat it as a limit, treat dx as h, and solve this and treat this as a limit of h as it approaches 0 of x to the h minus 1 over h, and we have to solve this limit and plug it back in. So limit as h approaches 0 is going to be x to the 0 minus 1 over 0, which is 0 over 0. This is indeterminate form. Thus we can use the L'Hopital rule, which is going to be ddh of x to the h minus 1 over ddh of h, which is going to result in limit as h approaches 0 of x to the h ln x. And if I now remove the discontinuity, I can plug in 0 for it. Thus it's going to be x to the 0 ln x, which is going to be ln x. Thus the expression here, x to the dx minus 1 over dx, is going to be ln x. And I just have to plug that back in to this integral. If you remember this integral, x to the dx minus 1 over dx. It's going to plug in ln x here. Thus, it's going to be ln x dx. How do we integrate ln x? Well, you can use the integration, sorry for my bad handwriting, by parts. It's so hard to write in tablets with magic pencil. So if we have an integral u dv, I can write it as uv minus v du. My u here is going to be ln x. My du is going to be 1 over x dx. My v here, dv, is going to be dx, and v is going to be equal to x. And if I want to integrate ln x, it is going to be x ln x. U equals ln x, v equals x, and minus the integral of v, which is x, and du times 1 over x dx, which is x ln x minus 1 dx. The antiderivative of 1 is x, which is going to be x ln x minus x plus see some constant of integration. Thus, our final result of x to the dx minus 1 is going to be x ln x minus x plus see some constant of integration, and that is the final form of our integral here that looks very scary at first. Thank you for watching my video. If you've liked it, please like and subscribe to my channel, and I will see you next video.